Hey, this last week I spent a lot of time in the shop doing some PCB work. I've never done any PCB design before, and so coming in it was pretty intimidating. I thought that I could just click on this PCB tool thing here from my schematic and get my components there, but it's not quite that simple. So I want to show you 8 tips that I came across in the past week to try to, they're really things that were blocking my progress, and knowing these simple things really got me from being intimidated to being productive. So let me show you these. The first is assigning footprints. I'm sure you've all seen a lot of schematics, but you may not have done anything with actual PCB stuff, so this is what got me the first time. So we just go to Tools, Assign Footprints, and then it's going to take a minute for these footprints to load. The schematic that I'm looking at today is something pretty simple. It's just a breakout board with some audio jacks and an Ethernet connection, RJ45, so that we can so that we could theoretically plug a test system into the board and quickly get all of those connections made. Okay, it's loaded 15,000 footprints. Pretty cool, right? It must have everything in it, right? Well, actually, it pretty much has only a few really basic things. So let me show you how this works. Over here we have the components on the schematic. We're going to jump back there in a second. And over here where it's blank, that's where our footprint assignments go. And so what we're going to look for first is this connection here. And so I always like to start searching for 2.54. Well, if I'm doing something that's 1-inch pitch, because it'll always say that. And then we're going to look for a connector that is 1x8. Let's see if we can find this. This one here looks pretty promising. If I right click, I can view the selected footprint. Here we go. Yeah, there we go. 8 pins, pretty straightforward. This is going to be the connection to the breakout. So I click over here, and I double click over here, and it makes that assignment. And then I can repeat the process for this 1x1 pin. Now, unfortunately, these audio jacks aren't in there. I just searched for audio 3.5 and it came up with a whole bunch, but none of them matched the actual footprint that I purchased, the footprint of the part that I purchased. So I've created my own library, and I'm going to show you how to do that in just a minute. So if we type in hardwired, my library. So I've got that here, this 3.5 millimeter audio jack, and I've assigned it to my audios. And we're going to leave this RJ45 blank for now because I don't have the footprint for that quite yet. We'll click OK. And now when we open this, it's still blank. Well, the magic here is you push F8, or if you like the menus, Tools, Update PCB from Schematic. And we can just click Update PCB, close, and here we go. Here we have our parts here. So let's zoom in. Arranging the parts is really pretty straightforward. To specify the size of the board, we use this edge cuts layer, click on the square, and then this got me. To draw a rectangle, you click once and then drag and then click again. Okay, so before we start drawing any traces, there are a few more things we want to do. We want to make sure everything's kind of in the right place, and we want to get some settings right so that we can get some good traces. So under File, Board Setup, there's some really important things here. Under Net Classes, we can define different classes, and these are basically the sizes of the traces that we're going to be using for different nets in the schematic. For example, ground or power might have larger traces than signal. And so the default that's in here right now says 0.2 millimeter clearance, 0.2 millimeter track width. These are probably the most important parameters here. These numbers are good because the fab that I am planning to use is 6 mil track width and track spacing minimums, and 6 mils corresponds to about 0.15 millimeters. So this is a little bit on the conservative side with 0.2 millimeter clearance, 0.2 millimeter track widths. And so we're going to keep that, but we're going to create a new pattern. I'm going to call this new one, we'll just call it plain old G, and it'll be our ground one. And we'll make those traces, I don't know, let's give them 0.5 millimeter clearance and 1 millimeter track width, just to be, much larger. So now that's there. This isn't enough. This just created the net class, but we haven't actually assigned it to the nets. The reason I called it G there is so we don't get confused about it down here. So over here, we create plus. The pattern, this is a string expression, and so I can put, I can just type GND, and over here it tells me that it matched the ground net. And then I need to set this class here to the one that I just created, G. Okay, great. So now when I draw traces from ground, they're going to be larger than when I draw traces from the other things. Okay, so back to this schematic. This is my breakout. I have this Con 0108, which is the pins that will plug into my proto board or into my breadboard. And then I have my switched mono jacks, and the tips of each of these are going to the odd numbered pins on this RJ45 and also to the odd numbered pins on this interfacing jack. And then because the RJ45 is twisted pairs, with the 1 and 2 being a twisted pair together, I've wired the second pin to ground. And I've also I've grounded all of these. I didn't really want to do that, so I'm gonna take off those normalized grounds in the schematic, and we'll see that update on the other side. Okay, a little bit late in the game, but I've revised the schematic. We have the even pins on the RJ45 going to ground, the odd pins going to the tips of our audio jacks, and then we still have the breakout getting these normalized connections for the audio jacks if we really want to. And so that way, if nothing's plugged into the audio jack, we'll get the even pin coming, out through the RJ45. Okay, but what I really wanted to show you is how to add a new footprint. And so I'd recommend going to the Kicad top level menu and doing the footprint editor here, because this should be impacting it globally as opposed to adding a footprint to this particular project. And so we'll go in this way. Okay, so new empty footprint, and then this is really important. This got me a bunch. So over here on the right side, we have these pink ones that you see in the schematic. We have margin and courtyard. Margin means that it won't run a trace through that boundary. Courtyard is just basically how big the component is on the PCB. And so we definitely want to mark the size of the component, so we want to have a courtyard. And not a margin, because we do want to be able to route those traces out. Okay, so the part that I'm using is this one here. And so we need to get this into Kicad. I haven't found a great way to do this in an automated way, but really it's not too tricky. So let's look quickly at this. So here we see 0.100 and then in brackets 2.54. Well, that must mean that this is 1/10 of an inch and this is 2.54 millimeters. Kicad seems to like to work in millimeters, and so we'll be using the numbers in the brackets. But the grid that it sets up, we'll set up all of these numbers out here are multiples of 50 mils, and so we'll set the grid at 50 mils. We have a 50 mil grid, so we can start laying down pads. Okay, so let's just put our first pad here. We'll move it later. That's not the shape that I want. So if I push escape, I can select this guy, push E for edit or properties. 0.9, we'll round that up to 1 millimeter diameter. Oh, this has got to be boring you. This part is super straightforward, so I'm going to whack down those parts and then show you my last few tips. When you want to create a hole, you want pad type NPTH for non-plated through hole, mechanical, and then you want to set the diameter to be the same for the pad as it is for the hole. A little counterintuitively, it's not a 0 diameter for the pad shape, it's the same. Great, now when I go to assign the footprints, I have my new Keystone RJ45. I can double click and get it here, and I can push OK. And now when I go into the PCB, I can push F8 and update PCB, close, and there is my RJ45 jack. R for rotate, something like that. Okay, so over here we can grab a trace. I like to use the blue copper here for ground, and that's where I'm going to start. And so I'll just click here and start drawing a trace up here. See how it's pretty thick? There we go. And then I like to use red copper for the signals. And so now you'll see when I start drawing when I start drawing these ones, let's see, so yeah, these should all come in here. That needs to go all the way up there. Okay, when I start drawing these, see how it will kind of automatically avoid those different things? I think I'm going to want to come up to the top here and come in this way, something like this. Okay, and then this, oh, that's going to be annoying, but it's okay. I don't like that. So if we want to come a different way, you can just click once and then it'll kind of save that point. There we go. And we'll just repeat this process for all the pins. Okay, another important distinction I'd like to make is the difference between this orange circle here and the one we saw in the footprint editor. This here, if I click here, I can and place one of these. This is actually a via. And you can make these larger to be the same size as these pads, but a via is solid copper in the middle. It's intended for connecting the top side of the board to the bottom side of the board, whereas this is a pad that has a hole drilled through it. And so don't be putting these on your board thinking that there'll be holes that you can use later. Initially, I thought maybe I could, instead of putting a part here that was a header, that I could just put these little vias here and have solder points, but they don't work well for that. Okay, so now I want to show you a really cool power tool. It's this here. It's called Draw Filled Zones. I also think of it as like flood fill. If you click on it, then you can start specifying a polygon, and this is going to be our ground plane. It's going to cover the whole back side of the board. But these go all the way through, right? And we don't want those to be shorted out. So it's smart about that. So we just click the when we click to place it, let's see, we want it to be on the blue copper, and we want it to be ground. And let's give it a name. We can call it G. Okay. And then we can start just tracing the edges here. I'm not sure if it's important, but I like to leave 50 mils of clearance between the edge of the board and the copper. Okay, we're not done yet. What we've done is we've specified the fill, but it's not actually filled. When you push B, then it will actually go through and fill it. And so now we see this nice blue covering the entire bottom of the board. Right, and we see it's avoiding, where all of these pins are here. So we have a nice, huge ground plane across the bottom, and we have our signal wires across the top. Okay, just one more tip that I want to make. If you go to print, this is actually super helpful because once my printer loads, we can tell it to, we can look at all the labelable layers that we're interested in. I like to do both layers of copper, the front silk screen, the front and back mask. This is where the solder mask goes. If there's solder mask, you're not going to be able to solder to it, so you want to know where that is. And the margin, right? And then we can print a separate page for each layer and print the board edges on all pages. And so then when I do a print preview, we get this nice illustration of what it's going to look like. These little black dots here are drill holes. But so we can quickly kind of flip through here and make sure that it mostly looks the way we expect it to look. There's our silk screen. There are pads on the bottom side. Good. Okay. It's always good to do a double check there. And then just one more quick thing I want to show you. You can install plugins. And in here, in the plugin content manager, under fabrication, that's where you can find these handy little utilities that will put together all of the layers that you have here and put them into a single zip file, and then you can upload that zip file to your PCB manufacturer of choice, and they'll have everything that they need, and you don't have to worry about selecting exactly which the layers are that you need to send to them. Okay, so that was a whirlwind tour of PCB design. And I am definitely not a pro here, but this is great software. It was definitely intimidating at first, but after sorting through all of those things, I feel pretty good about it. And so I've shown you assigning footprints, placing components, board setup, specifically net classes and the widths of the traces, how to create a new footprint, assigning the footprint to a component in the schematic, and then refreshing and seeing that happen in the PCB. We talked about drawing the traces to connect the various things, a distinction between pads and vias, the flood fill, and then a quick tip about printing and about plugins. Wow, that was 10 things. Okay, I hope you enjoyed the episode. See you next time.